Good morning, friends. Welcome to the T.Y.B.Sc distribution theory class. In today's lecture, we will see the Cauchy distribution. In Cauchy distribution, we will see the PDF of Cauchy distribution function, and by using the distribution function, we will see the how to find out the quartiles of Cauchy distribution. Before going to start the Cauchy distribution, we will see the application of Cauchy distribution. Okay, there is so many theoretical applications are available in the s- theoretical statistics like the inferential statistics. There is so many applications are available in Cauchy distribution. Mostly the Cauchy distribution has application in the asymptotic inference, which is you will be studying in the MSc or postgraduate level. But in real life, there is some applications are available in the spectroscopy department or hydrological department. There is some of the applications are available. Mostly in the hydrology department, there is maximum one day rainfalls and river discharge. There is the extreme events occurred in a real life situation. So that case, uh, we will fit the Cauchy distribution to rank the monthly maximum one day rainfall, showing also the 90% confidence built based on the binary dish. These are the some examples are uh, available in uh, internet or whatever. So this application you can see in the web. So, okay, now we will continue the definition of Cauchy distribution. So, the definition of Cauchy distribution. A continuous random variable, a continuous random variable x is said to follow Cauchy distribution with parameter mu and lambda if its probability density function, that is PDF, is given by f of x equal to lambda upon pi 1 upon lambda square plus x minus mu bracket square. Okay, this is the PDF of Cauchy distribution, but where the range of x, that is random variable x, and parameter is your range of x is minus infinity to infinity, and mu is also lies between minus infinity to infinity and lambda greater than 0, and 0 otherwise. This is the PDF of Cauchy distribution. Generally, it is denoted as x follows Cauchy with mu lambda, or some books refer as x follows Cauchy mu lambda. These are the notations of Cauchy distribution, or you can see it that like this. Okay, so uh, one remark we will see here, that is you can see in the normal distribution, that is standard normal distribution. Same here we can see the standard Cauchy distribution. Okay, now I have to say it as remark, that is standard Cauchy distribution. Okay, so if I have put here as mu is equal to 0 and lambda is equal to 1, then the density function of Cauchy distribution is lambda upon pi, that is 1 upon pi into 1 upon lambda square, that is 1 plus x minus mu. Mu is 0, so x minus 0 is x bracket square, that is x square, where x is lies between minus infinity to infinity. So that is your x has a Cauchy distribution with parameter 0 and 1. This is known as standard Cauchy distribution. Okay, so this density function is called as standard Cauchy distribution density function. Okay, now further we will see the distribution function of Cauchy distribution. Okay, here we will see the distribution function. Okay, now we have given that x has a Cauchy distribution with parameter mu lambda. So their density function is f of x is equal to lambda upon pi 1 upon lambda square plus x minus mu bracket square, where x is lies between minus infinity infinity, mu is also lies between minus infinity infinity, and lambda should be positive 0 otherwise. Okay, this is the density function of Cauchy distribution. Now consider the distribution function of x, that is f of x, which is equal to probability of x is less than equal to x. And in continuous random variable, how to find out this probability? We can take the integration over minus infinity to x f of x dx. This is the by definition of distribution function of continuous random variable. Now here I have to put the value of f of x here, so that is integration over minus infinity to x lambda upon pi 1 upon lambda square plus x minus mu bracket square dx. Okay, here just I have to put the value of f of x in this integration, we get this. Okay, now for simplicity here we will put the t is equal to x minus mu. That means your value of x is mu plus t, or the derivative of x with respect to t is dx is equal to dt, or dx by dt is equal to 1. Okay, this is the just substitution. Now further we will substitute this value as in this distribution function. So your f of x is equal to lambda upon pi, which is constant. We have taken outside into the integration sign. So integration over minus infinity to this is your x minus mu, since your new random variable is t. So you have to go from the minus infinity to t, and t is nothing but x minus mu 1 upon lambda square plus x minus mu is t square dt. Okay, and we know that this integration is nothing but the your lambda by pi into this integration is tan inverse of t by lambda. This is the tan inverse of t upon lambda, and this t upon lambda with respect derivative with respect to t is your 1 upon lambda over the range minus infinity to x minus mu. Okay, now I have cancelled this lambda with this lambda. We get 1 upon pi your tan inverse of x minus mu upon lambda minus tan inverse of minus infinity. Okay, so this tan inverse of minus infinity is nothing but the minus pi by 2. Okay, so your finally the distribution function is like this: 1 upon pi tan inverse of x minus mu upon lambda, and this minus pi by 2 and this minus, we get the plus pi by 2. Okay, or you can simply write it as 1 upon pi tan inverse of x minus mu upon lambda plus 1 by 2. Okay, this is the distribution function of Cauchy distribution. Okay, this is your distribution function of Cauchy distribution. Remember these distribution functions because so many times we can use the distribution function to solve the examples, or most of the case that is in the fitting of Cauchy distribution, that time you can use this distribution function for the fitting purpose. Okay, now further we will see the quartiles. Okay, now we want to find the first quartile, that is q1 so we find it as f of qi is equal to I by 4, where I is equal to 1 to 3. Okay, now we want to find the first quartile, that is I is equal to 1, that is f of q1 is equal to 1 by 4, and we know that this f of x is nothing but your 1 upon pi tan inverse of, we just replace as x by q1, so your tan inverse of q1 minus mu upon lambda plus 1 by 2. This term is that equal to 1 by 4, or you can just write it as equal to 1 by 4. Now I have to subtract this here, means I have to subtract this 1 by 2 here, add, we have to go to the right hand side, this is the subtract. So your 1 upon pi tan inverse of q1 minus mu upon lambda is equal to 1 by 4 minus 1 by 2, that is equal to minus 1 by 4. Okay. Now you can write it as tan inverse of q1 minus mu upon lambda is equal to, this pi is here denominator, you can go here the numerator, that is minus pi by 4. Also this are taking the tan, so we get q1 minus mu upon lambda is equal to tan minus pi by 4. Okay, and we know that the tan minus pi by 4, this tan minus pi by 4 is nothing but minus 1. Okay, so your q1 minus mu upon lambda is equal to minus 1, or we can write it as q1 is equal to mu minus lambda. This is your first quartile. Okay. Now similarly we will find the second quartile. Also we know that for the finding the second quartile, your f of q2 is equal to 1 by 2, or we can write it as 1 upon pi tan inverse of q2 minus mu upon lambda is equal plus 1 by 2 equal to 1 by 2. So this 1 by 2 is going to the right hand side, we get 1 upon pi tan inverse of q2 minus mu upon lambda is equal to 1 by 2 minus 1 by 2 is 0, or we can write it as tan inverse of q2 minus mu upon lambda is equal to 0. That is your q2 minus mu upon lambda is equal to tan 0, and we know that the tan 0 is nothing but the 0. This value is your 0. So we can write it as q2 minus mu upon lambda is equal to 0. That means we can write it as q2 is equal to mu. This is the second quartile. Okay. Now further we will see the third quartile, that is f of q3 is equal to 3 by 4. That means your 1 upon pi tan inverse of q3 minus mu upon lambda is plus 1 by 2 is equal to 3 by 4, or we can simply write it as 1 upon pi tan inverse of q3 minus mu upon lambda is equal to, this 3 by 4 minus 1 by 2 is nothing but the 1 by 4. Okay, this is just plus 1 by 4. Now so your tan inverse of q3 minus mu upon lambda is equal to pi by 4, or we can write it as q3 minus mu upon lambda is nothing but tan pi by 4. Okay, and we know that tan pi by 4 is plus 1. Okay, this value is nothing but the plus 1. So your q3 minus mu upon lambda is nothing but 1, or we can write it as q3 is equal to mu plus lambda. This is your third quartile. So what we have to see in here, your first quartile, that is q1 is equal to mu minus lambda, your second quartile q2 is equal to mu, and third quartile is equal to mu plus lambda. Okay, this is the three quartiles or quartiles of the Cauchy distribution, which is very simple to remember. Okay, so Now we will stop here. In next lecture, we will see the some examples of Cauchy distribution. So thank you, thank you,